Okay, hello everyone. This is video 2-14 to be watched Wednesday 10/19, and the homework, just like last night, is only one problem. It's page 22, number 1. Okay, so we're continuing with complicated derivatives. So differentiate the function below, express your solution without negative or fractional exponents. We don't have to do that. Okay, this is complicated enough. Now, other rules inside of chain rule. Yesterday we had chain rule inside of product rule and quotient rule. This time we're going to have quotient rule inside of chain rule. Okay, so take a look at this. So right off the bat, I notice that I have a function inside of a function. I have this function, which is a quotient, inside of a radical. So right away I know I have to use an in and out chart in order to use the chain rule. And by the way, guys, in the future, or there's going to be some situations where you know it's chain rule and it's like you're getting fast at it, so you don't need to write the in and out chart. Some people are not going to ever feel comfortable without the in and out chart. Not this year anyway. In the future you will. Like Calc 2, Calc 3, whatever. But this year, use it as long as you want, as you need to. And if you ever feel like you're past it, then that's fine. Okay, so, but a situation like this, you definitely want to use it. So the inside function is x to the second plus 7x minus 6 over 4 minus 2x to the fifth. Now here, I'm going to be taking the derivative of this. There's no way around the quotient rule. We've done some exercises where I asked you to stop and think, do you really need the quotient rule? And like if this was a monomial, like if this was just 2x to the fifth, the answer would be no, because you could split this up, x to the squared over, x to the second over that, plus 7x over that, minus 6 over that, and then, convert so you could use the power rule. But this is not a monomial. This is a binomial. We need the quotient rule here. What is the function that this is inside of? It is blank to the 1/2. Okay, I just converted the radical so I could use power rule. Now, I need quotient rule here, so I'm going to set it up with brackets. I'm going to set up the whole thing. Yesterday there was a situation where I only set up the numerator because I saw that I would need to use chain rule inside of quotient, but I'm not going to need chain rule for either of these derivatives, so I'm setting up the whole thing over blank squared. Okay, now I'm putting parentheses around this whole big thing because I'm going to have the derivative of the outside function coming down next to it. Okay, so in here goes x to the second plus 7x minus 6. And here goes the denominator, 4 minus 2x to the fifth. And I just write those again. X to the second plus 7x minus 6. 4 minus 2x to the fifth. 4 minus 2x to the fifth. Okay, so I'm going to take those derivatives in a moment. I might as well just take the derivative of this now because I'm right here. I'll finish this line in the problem. Power rule, 1/2 blank to the 1/2 minus 1 is negative 1/2. What goes back in? The old inside. So x to the second plus 7x minus 6 over 4 minus 2x to the fifth. Okay? So I'm going to take the derivatives of the stuff inside the brackets with the primes. So I'm going to have two more lines. So I'm going to have another line where I take the derivatives of what's inside the brackets with the primes, and then I'll have a third line, which is my final answer. And I won't simplify a whole lot, but I'll make it so that it looks aesthetically pleasing. Okay, so the derivative of this one, I've got 2x, and go ahead of me, guys, if you've got this. 2x plus 7, and then 4 minus 2x to the fifth, minus, just bringing that one down, x to the second plus 7x minus 6, taking the derivative of that, negative 10x to the fourth, all over 4 minus 2x to the fifth, bringing all of this stuff down, 1/2, so times 1/2, and then x to the second plus 7x minus 6 over 4 minus 2x to the fifth to the negative 1/2. All right, now I'm going to write my final answer. And I take a look at this. You don't have to simplify stuff, guys. The only thing I can see to simplify would be to, put this back in radical form. But that wouldn't, I don't know. When I think of simplify, I think of make it look more simple. And I don't know that that would. So all I'm going to do really is I'm going to take this 1/2 and I'm just going to rewrite it as just a 2 in the denominator here. You don't even have to do that. I just, it's more pleasing to my eye. So g prime of t equals, I've got 2x plus 7. So you could even stop, guys, where we were up above. 2x to the 5th minus x to the 2nd plus 7x minus 6. Ah, crap. Actually, I think it'd look even nicer if this was a plus 10x to the 4th. I'm writing in pen though. Okay, negative 10x to the 4th over 2, 4 minus 2x to the 5th times x to the 2nd plus 7x minus 6 over 4 minus 2x to the 5th to the negative 1/2. And yeah, this would look even better for me, guys, if this was plus 10x to the 4th times that trinomial. All right. Not a big deal. Okay, so there's that. Homework is only page 22, number 1, and I will see you soon. Bye-bye.